kind of concentrates on the left or the right, or if it's perfectly symmetrical. Again, I'm able to just make predictions about something. I'm able to go and tell my dean that based on this normal curve that the majority of the people make between this, and if I grab somebody an average, just randomly, their average would be within this normal curve. But if it's positively or negatively skewed, it can look a little different. To calculate skewness, and it's much easier to do this in Excel, so we'll go through how to do this. The skewness is going to be between -3 and 3. Remember those standard deviation points we talked about, 3 and -3? Well, the skewness is going to be between those two numbers. And it just tells me to what degree something is off of being normal. So 1.63 would be moderate positive skewness, negative 1.63 negative, moderate negative skewness. 0 would mean that it's perfectly symmetrical, which not very much is that, but we will be dealing with the normal curve in most of our experiment or problems that we have in future chapters. So skewness is going to be the mean minus the median times 3 divided by that standard deviation. We're not going to be dealing with the software coefficient of skewness. You can thank me after the test that we're not testing with that. So here's another way. If I gave you the median and mean and just the scores, that you'd be able to tell me if it's negatively or positively skewed without graphing it. So if my median is smaller than my mean, then I know that it's positively skewed. Positive means that it's on the left. It bubbles on the left. Negative, it bubbles on the right, and that the median is going to be bigger than the mean. If they're both about the same, then it's pretty symmetrical to normal curve. And again, we're going to be dealing with normal curves for the most part when we deal with hypothesis testing, because it's making an assumption that everything's going to follow a normal curve, that you don't have the people making zeros as much or hundreds as much. It's more of in the middle. We won't be dealing really with bimodal anything, but again, referring back to the last chapter, know that you can have several modes. You can only have one median and one average. An example for skewness, I have this information on the 15 software companies 2007, their earnings per share. I want to compute the mean, median, standard deviation, and the coefficient of skewness, and then what conclusion can I make? Not as much now, but in the future test after the midterm, I'm going to ask for your interpretation. I don't want to just know what the answer is. I want to know in English, in real terms, in real world business terminology, how would you interpret this data? Don't use terms out of the book. I want to know as a manager, what does this mean to you? So that's kind of the translating we're doing right now, taking these statistics concepts and translating them into business concepts. So here I want to compute the mean. Remember, the sigma means the sum of all the x's divided by n. So I come up with the average is 4.95. And I want to compute the standard deviation. Again, I'm subtracting each number from the mean from each number and squaring it, adding them all up. We're dealing with a sample, so it's going to be divided by n minus 1. If this is where you mess up, your answer isn't too terribly far off, but it will make a difference. Find the median, that's just the middle value, and it's 3.18. And I want to calculate the skewness, excuse me, which is going to be the 4.95 minus 3.18 divided by the standard deviation. And I come up with 1.017. So it's slightly positively skewed. And then what would that mean is as I go back, why am I not going backwards? So to interpret that, you see where it's positively skewed. To interpret that as a manager, then we'd say that, okay, for the most part, we don't have, our earnings per share seem to be a little bit lower than the average in a normal curve. If it was the other way, hey, our earnings per share are higher than the average. One way that we can look at relationships is through a scatter diagram, and you can do this again in Excel. You type in your data and you click on it and it brings up this pretty graph, and I can kind of see trends. Here I see that there is a trend here, that the cost of maintenance for a school bus goes up as the age goes up. That makes sense. Here I can see auction price and odometer goes down. Usually the lower the odometer or higher the odometer, the lower the price that you can get for it. And here, salary versus how tall you are. There isn't any sort of relationship at all, at least according to this data. Part of the correlation has to deal with if it makes sense that it's related. Cost and age for maintaining something, of course, that's going to make sense, or auction price compared to the product itself. But you look at these aren't necessarily causing one another. Just because I'm taller or shorter doesn't mean that I'll make more money. So causation and correlation aren't necessarily hand in hand. Here I have a relationship between two variables using Excel. If I type everything in, I have the price for these vehicles, the age, and the type may be it's used or new or whatever it is. We have this information on these 80 vehicles sold at this Autoplex in Missouri. The data shows the selling price of the vehicles and the age of the purchaser. So these are the age of the purchaser and the type of car, whatever type they were referring to. Is there a relationship between the selling price of the vehicle and the age of the person buying it? So sometimes they'll give you data that you don't really need right now. Like I don't necessarily need to know the type of car. All they want to know is what's the relationship between the age and the selling price. And would it be reasonable to conclude that the more expensive vehicles are purchased by older buyers? Now, if you think about that logically, that kind of makes sense. The older we get, our income goes up, we buy nicer cars. So causation-wise, it makes sense. But we're going to see if there's actually correlation. And when we type this into Excel and graph it, there is a relationship, and it's a positive relationship that we see. Not everything follows it, but again, this is for the majority of the data, not just for every individual. Contingency tables help to split up data. It's a little bit easier to read sometimes. It needs to be at least an interval scale. And it shows summaries of cross tabulations, usually for two variables or more. For instance, I have students at university classified by gender and class rank. So I might have class rank at the top, graduate, undergraduate, if that's what they want to use, and then male or female, and then I can plug in the data. So here's an example. Here the afternoon, or the shift that you have, day, afternoon, and night, and then I have product is defective or acceptable. So this is a window manufacturer, and they grab 50 items. So right here in this right lower corner, this is going to be the total number that you have, your total in. And this is dividing it up according to, these are all the day shift totals, afternoon, night, and these are all the defective and acceptable ones. So all of these across here and all of these across here should add up to 50 to double check yourself. So using a contingency table, the quality of the three shifts can be compared. For example, on day shift, 3 out of the 20 or 15% are defective. So 3 out of this 20, 15% are defective. For the day shift, I can quickly see where the most defective products come from, what shift, or how many are defective as a percentage. 44 out of 6 are, or 44 out of 50 are acceptable as compared to the 6 out of 50. And then what I might give for examples, I didn't know it was going to click off. Let me get back to it. So what I might give you for questions would be these right here. What is the percentage of defective on night shift? It would be 1 out of 15. Or defective on night shift compared to the total that I produced. How the problem is worded depends on how you answer it. So it would be 1 out of 50. Okay, so those are just questions to practice. Let's start a little bit on chapter 5.